resistors are said to be in series whenever the current flows through the resistor sequentially. The equivalent resistance of a set of resistors in a series connection is equal to the algebraic sum of the individual resistances. The current through the circuit depends on the voltage applied by the voltage source and the resistance of the resistors. For each resistor, a potential drop occurs. This is equal to the loss of electrical potential energy as the current travels through each resistor. One result of the components connected in a series circuit is that if something happens to one component, it affects all of the other components. For example, if several lamps are connected in a series circuit and one bulb burns out, all the other bulbs will go dark. Series resistances add together to get the equivalent resistances. The same current flows through each resistor in series. Individual resistors in series do not get the total source voltage but divide it. The total potential drop across a series configuration of resistors is equal to the sum of the potential drops across each resistors.
At this juncture, I will present and tackle to you the objectives, material, and the diagram of this experiment. The objectives of this laboratory experiment is to verify the principles that govern the resistance which are connected in the series. The specific material of the apparatus that was utilized is the PHET simulator, circular construction kit, DC, or the direct current. The following slides that will be presented are the diagrams from trial 1 to trial 3. Each diagram included two resistors, a battery, switch, and some wires in order to determine the current and the voltage. Additionally, the 3 ammeters and the 2 voltmeters are also included, which are also essential parts of the simulator circuit.
Procedure. We, the students, access the PHET simulator circuit construction kit DC. Then, we identify the important parts of the circuit and analyze how to utilize the respective apparatus. The PHET simulator includes the wire, battery, light bulb, switch, voltmeter, and ammeters. Basically, these were used to construct our circuit. To construct the circuit, first, drag 2 voltmeters and 3 ammeters, followed by the wires, battery, and 2 fixed resistors. Lastly, we drag the switch. These materials that were dragged in the medium of the screen of the PHET simulator were respectively placed in accordance with the student's choice of layout. Third, connect the ammeters, switch, battery, and resistors using the wire. The value of the resistance can be changed comparing to the student's choice. Then, connect the probes of the voltmeters to the opposite sides of the resistor, and eventually determine the value of its resistance, current, and voltage. In order to close the circuit, simply click the bottom part of the switch. When the values are already shown or revealed, take note of it right away. Encode the following data shown from trial 1 to trial 3 in the table given in the laboratory experiment number 5 worksheet. Take note that the value of the battery in voltage is held constant. After encoding the data of each trial, understand and analyze the diagrams thoroughly. Lastly, proceed to the next part of the experiment by answering the computation, discussion, observation, analysis, and conclusion.
Tables and computation. At this moment of time, let me discuss the table and computation of laboratory experiment from trial 1 to trial 3. The value of the resistant 1 and resistant 2 are correspondingly increasing. This results to the total value of resistance is also increasing. In the finding value of the total resistance, we add up the value resistant 1 and resistant 2 in each trials. Specifically, the total resistance from trial 1 to trial 3 has the value of 20 ohms, 23 ohms, and 26 ohms. In terms of current, the value of current 1 and current 2 are the same or equal as the value of the total current. To be specific, the total current from trial 1 to trial 3 are decreasing with the value of 0.86 ampere, 0.70 ampere, and 0.59 ampere. On the other way around, when it comes to the voltage 1, its value is different from the voltage 2. From the voltage 1, its value from trial 1 to 3 are increasing, such as 12.86 volts, 13.95 volts, and 14.71 volts. For the value of voltage 2, its values are decreasing. From trial 1 to trial 3, the values are 17.14 volts, 16.05 volts, and 15.29 volts. Lastly, in finding the total value of the voltage, we can just simply add up the value of voltage 1 and voltage 2. Therefore, in this laboratory experiment, the result shows that the sum of the total voltage from trial 1 to trial 3 are all the same with the value of 30 volts. Simple as that. Now, the following images are the table and computation of this laboratory experiment in order for you to understand in verifying the principle that govern resistance which are connected in series.
Hi, my name is Joshua Daniel Casco, and I'm gonna present to you the discussion of our lab experiment. For the discussion, in current and resistance, we describe the term resistance and explain the basic design of a resistor. Basically, a resistor limits the flow of charge in a circuit and is an ohmic device where most circuits have more than one resistor. If several resistors are connected together and connected to a battery, the current supplied by the battery depends on the equivalent resistance of the circuit. The equivalent resistance of a combination of resistors depends on both their individual values and how they are connected. In a series circuit, the output current of the first resistor flows into the input of the second resistor. Therefore, the current is the same in each resistor. According to Ohm's law, the potential drop across a resistor when a current flows through it is calculated using the equivalent V equals I multiplied by R, where I is the current in ampere and R is the resistance in ohms. Since energy is conserved and the voltage is equal to the potential energy per charge, the sum of the voltage applied to the circuit by the source and the potential drops across the individual resistors around a loop should be equal to 0. One result of components connected in a series circuit is that if something happens to one component, it affects all the other components.
Our analyzation in the laboratory experiment, we state that the resistors are said to be connected in series when they are daisy chained together in a single line. Since all the current flowing through the first resistor is no other way to go, it must also pass through the second resistor and the third, and so on. Then, resistors in series have a common current flowing through them, as the current that flows through one resistor must also flow to the others, as it can take only one path. Then the amount of current that flows through a set of resistors in series will be all the same at all points in series resistor network, in which total current is equals to I1 and is equals to I2. As the resistors are connected together in series, the same current passes through each resistor in the chain, and the total resistance of the circuit must be also equal to the sum of all individual resistors added together. That is, total resistance is equals to R1 plus R2. In the experiment, it proves that the voltage drop across a resistor in a series is directly proportional to the size of the resistor, since as it also increases the size of the resistor in every trial, the voltage across the resistor also increases.
Based on our results in the table, we conclude that the current of the resistors 1 and 2 and the total current is equal. The current is the same through each resistor. The total resistance of the circuit is found by simply adding up the resistance values of the individual resistors. This applies in all the 3 trials, and the voltage in each resistor is different. The total voltage is divided accordingly to the value of both resistors 1 and 2, thus having the same total voltage in all trials but different voltage value in each resistors. Furthermore, when it comes to series connected resistors, the value of current will remain constant. The individual values of resistance will be simply added up to get the total resistance, and consequently the total voltage across the resistors will be measured by adding up the individual voltage values in the individual resistors.